Welcome back. The website I wanted to talk about was Godbolt, or Compiler Explorer. The purpose of this website is that you can write any code in plenty of different languages and see the bytecode or assembly output for it. This helps a lot of people just to satisfy their curiosity, learn how compilers optimize things, and also for compiler developers to see how existing languages will generate assembly code and basically learn from it. Now we can start by writing a little sample C program. After a brief period of you not typing, it's going to assume you're done and it's going to compile it. Now, as you can see, you have the ability to hover over pieces of the code and how they reflect on the assembly itself. We can see that these variables are at an offset in the stack, and they're being assigned and then being loaded in later to perform the add operation, which is done here. And then since the result is an EAX, it's then loaded into the memory location for C. But if you actually notice something, this entire thing is very redundant because you're loading it and then you're reloading it back. So now what we can do is actually do something like this. We can do /O2. As you can see, it's completely optimized our output. As you can see, it did the addition over here since it knows the variables aren't going to change. So it does the addition actually at compile time. And then it stores it in the ESI register. It stores the string into the EDI register and then calls printf. You can actually lower the optimization. Actually, it doesn't really change anything. And we also know that, for example, if we actually don't do a print here, it's just going to optimize everything out because the entire program kind of serves no purpose. Now, this is all cool and amazing and whatever, but what is all this stuff? I mean, we can actually add in more stuff and I guess read the ELF. Wait, no. Whoops, actually I don't know how to use this. Clang format, a bunch of other stuff. We can add new an executor from this, so it actually executes the code for you. So it's also like a nice playground to, I don't know, run your code. And also, by the way, you can rearrange all this stuff, and it's a really nice UI. You can also view the preprocessor and what the preprocessor is doing. We can do this by, I don't know, making a really annoying preprocessor here where it's completely pointless, don't worry. But I'm just gonna make it so I can show you how this actually will work. So now I'm gonna switch to Vim mode. And yeah, it actually does have Vim mode. I don't know how feature rich it is, but yeah, they do have it. And then CD. Okay. As you can see over here, the code really doesn't change because it's unpacked those macros. So this is also really, really useful. And you can look around here. You actually can add some libraries if you would like to. And there's this stuff too, like GCC tree. Okay, I don't know, that wasn't working, but we can also over here, we can uncheck some of this stuff and it'll give the assembly kind of more raw, I guess. And if you put the comments, you can actually see what code it's talking about, which to us it's not really that useful because Godbolt will do this for us by hovering. Another thing we can do is deselect this if you like the gas syntax. And before I move on, this is another feature to move on to a different language. we have like 1,000 different options for a compiler. It's actually kind of incredible. So we can do an ARM64 compiler and see what we get here. There we go. I actually can't read ARM assembly. It's a work in progress. I'll learn eventually. We can also see other compilers like, let me look at a really, long arch. Let's check this out. There we go. Let's take a look at something like, I think ZigCC is like a fork of Clang, or maybe, I don't know. Don't correct me if I'm wrong. Don't take my word for it. I'm looking for, oh, I forgot I could just search TCC. There you go, TCC. TCC is incredibly unoptimizing, but as you can see, its assembly is it's a lot more messy, I guess, but yeah. Finally, I'm going to do one more, and I'm going to do Clang. And the reason why I'm doing Clang is because Clang can do something really nice, and that is, first of all, the code doesn't really look too different, but this is what it can do. What the hell just happened? What the hell? Okay, so all the people that use LLVM to, write their compilers and stuff, it can actually emit LLVM IR. And this makes life especially easier if you are trying to figure out how LLVM IR works. And let's say like you have your own programming language and, I don't know, you declared like a variable or something and your IR is not working and you want to debug it and see how, Clang does it. This is really useful because now you can write the same equivalent code in C and basically see that, I promise I'm not making a C pun, but you can look at and see how the LLVM IR looks like and everything like that. Now we can move on to other stuff, like, for example, C++. Actually gives me a thing here. Let me try to write some code here. Hold on. Oh, there we go. So if you do this, if you uncheck this, it'll actually show you the not demangled names. And you click this, it'll show you it will demangle them, so it's a lot cleaner for you to see. This is also pretty useful, and yeah, I just wanted to show that. Now we can actually look at other languages that don't particularly compile to, let's say, I don't know, LLVM IR or assembly. Zig here compiles to LLVM IR, I think. I don't know if they still do, because I heard there were talks to get rid of LLVM, but holy shit. Oh my god. Okay, I did not expect that much assembly. Oh, because of the whole panic and integer overflow. Okay. Now, certain languages actually compile to C, and one of the examples is V. V compiles down to C, and you can actually see the C output. Holy crap! I'm so sorry. I'm not trying to make a C pun constantly, but you can actually see some of the types here that are internally known for V, but they're casted as something else. And it'd be really helpful if they could, I don't know, let me. I think it's gonna be at the bottom. Holy crap, this is ugly. I think this is it. Main underscore main. Yeah, okay, so println int underscore str, so it's converting the integer into a string and then calling main square 3. So yeah, this is what V does. And we can also see some other stuff here. I think TypeScript too. Rust would be pretty similar to Zig. I don't know what nim compiles to. Should really curious. Oh, compiles. Okay, cool. Go, I think Go will show up as some sort of like intermediate representation. I think, or am I mistaking it with something else? But let's see. Yeah, it does actually. So you can see what it kind of compiles down to. And what else? There's one. Where's Java? I wanted to show Java. Again, this shows the IR basically, and you can see that the square loads the variable, multiplies them, and returns them. Oh, Python, sorry. There we go. This is the Python bytecode. And finally, this is a really interesting trick I use when writing assembly. So I really, really, really hate writing assembly macros. And I actually probably forgot how to write one of these. This is like assign one, sorry, I 0. And sorry, it's a percent sign. Okay, I totally forgot. I haven't written assembly in a while. Give me one moment. Okay, I'm back. So I figured out how to do that and totally did search up my previous code. But regardless, this is an assembly macro that assigns the value 0 to I and repeats this entire block 10 times, and every time at the end it assigns 1 to 1 plus 1. So it's like a for loop, but in a macro. Assembly macros are actually pretty cool. Now this will result in 10 functions from 0 to 9, and these macros are kind of annoying to use in terms of their documentation isn't the greatest, at least in my opinion. So using Compiler Explorer to kind of test out the macros is actually a really good way to use Compiler Explorer. It's probably like my most favorite way to use it. Okay. Anyways, thank you guys for watching. I'm sorry if this video was kind of all over the place. I didn't really plan this video. It kind of came to me like last second. So yeah, thank you guys for watching. Let me know what you guys think. I hope this video introduced you to a really nice website, and I hope you guys like it. Thank you. Bye.